as they dish out valuable lessons learned from their experience at companies like REA Group, Slack, and Couch. Please give it up for Javier and Trent.
First of all, thank you so much for coming to our session today, and thank you to the organizers for having us speaking today. It's the idea of this talk really started as a conversation. We were thinking, what can we do to make it like a talk that is a little bit different from the usual talks? We're thinking about the value that you find when we're having these kind of hallway conversations, and we're having chats with our colleagues about like when things went wrong, all these war stories and what you can learn from it, and how valuable that is. So we thought we will try to simulate that in our talk today. Let's see how it goes. May has done an introduction, but we have some for ourselves as well here. So let's kick off with that. Trent.
Hey all, I'm Trent. I'm an AWS architect. I've been fortunate enough to work at a few places around Melbourne here, and I'm currently hosting jobs at Seek.
Amazing. And I had the pleasure to start my career here in Australia at REA Group, where I had the pleasure to work with Trent and few people in the audience. They probably know some of the stories we're going to talk about today. Then I moved on to work at Slack, where I spent 3.5 years. Really interesting incidents there, really interesting culture. And now I'm working as director of engineering at Canva. As May said, I'm also one of the co-organizers of the DevOps Represent group, which is a group that supports people from underrepresented genders in tech to go into DevOps by providing like free training and support as part of the community. So we were talking about incidents and lessons learned. What is your first memory, Trent, about an incident in the cloud?
Yeah, so...
I jump ahead.
I know, yeah, just...
That's all good. Wanted to start first with this quote from Werner Vogels that talks about how failure is everywhere and you cannot avoid it. Everything fails all the time, and you need to get prepared for that, and you need to think ahead before that failure happens. It's inevitable, it's going to happen, so what do we do about it? Yeah. And then we move on to your first story about what happened?
Yeah, so when Javier and I were planning this talk, one thing that came to mind was like, what are some of the key incidents that we remember? And one of them was this one at the Red House. So to take you back to 2008, so REA started looking at using AWS in 2008, and then by 2011 decided to go all in on the cloud. So at the time, dev environments were a massive point of contention for REA Group. It was really hard to get stuff done. So the way REA solved this problem was to provide an end-to-end environment for every single developer within AWS. So that works out to be about like 10 EC2 instances for 60-odd developers. So over time, that became expensive. And so to mitigate that expense, REA implemented a tool to stop these instances out of hours because no one was working at 3 a.m. So the tool was created, but realizing that we weren't getting that saving from that tool because there was a bug in the tool. So I remember coming in, but it wasn't working. So I remember coming in one day, 9 a.m. after the coffee, and there were screams. Basically what had occurred was there was a change that was made to the stop and edit tool that didn't just stop instances, it terminated the instances, and it didn't filter on tag, it destroyed everything. It destroyed the entire AWS environment for REA Group. It was painful. This is 2011. And so this affected 60-odd developers. And what was worse was that these environments, these end-to-end environments were hand-rolled. So it impacted these developers for over a week to try and reconcile these environments and recreate. It was massively painful for REA. The PIR for this incident was really interesting, and there was really two things that came out of it. Firstly, there was no test and release process for this tool. And there was no way to limit that blast radius for whenever a change was made to limit the blast radius of that change. So that was one thing. The second thing was that REA was treating all of their environments in AWS like data center. They were treating them as pets, not cattle. And I remember speaking to the CTO at the time saying, this is so painful. I'm spending all this time to recreate environments, I'm so annoyed. And the CTO just said to me, look, Trent, it's the cloud. You built your shit wrong. You just got to build your shit well. So then
Before we move, I was chatting to someone in the audience about this very same incident before we came in, and he shared that he's still having nightmares of when this happened and all the implications that it had. So I'm very glad that we introduced this one here.
So I guess those concepts of building for failure really put REA in a good position. The learnings from that is that it put REA in a good position for the first production workload in AWS, and that was the image serving of the website. So the timestamp this was 2012 before the Sydney region. So taking those lessons from that incident, the image serving was pretty straightforward. All of the images were stored in an S3 bucket and then dynamically resized on the way out with EC2. So we're baking AMIs, injecting environmental configuration into these AMIs when we launched them to then serve up those images. The big portion of REA traffic is property porn, and so it was really important that the solution worked. The second element of this is REA was hosting their website prior to going to AWS in 2 data centers, active. And so REA wasn't really confident about this whole region concept, so decided to deploy this multi-region. And that was really the architecture that we went with in 2012 for the image serving. It put REA in pretty good stead and gave it a lot of confidence around running stuff in the cloud. And then REA took the next step when it came to China.
Yeah, that was one of my first project, building something in AWS. And we were very lucky that this was a greenfields project where we could start afresh, really think about what do we want to build here. We're building the myfan.com website, which idea was to put some of those property listings up in the market in China. The year is 2013, and that's me with one of my colleagues in the office in China trying to figure out how we're going to build this thing. I really want to take advantage of the new things that were coming from the cloud, and I really wanted to make this project an example of resiliency, so we could implement it in some other places. If you are doing a greenfield project, that's much easier than if you already have something that you're trying to introduce these things into, and this was a great opportunity for us. So we're sitting thinking hard about how we're gonna make this happen, and this is kind of a very simplified view of the architecture at the time. We have a consumer of the website coming through a CDN, it goes into load balancing and hits a web server. That's very standard. So this web server had 2 dependencies. One of them is a location service. It's a service that will give you the distance between the property and where you are, and that's its sole purpose. The other one is a search engine. We were making it easy for people to search for property, so that's a very important component. So we're now thinking, well, what happens if any of these components break? And what we did is, before going live, we started to purposefully break in each one of the components. So we started bringing down one of the nodes of the search engine, and automatically another element will pick up. This was all part of a cluster, so no dramas, it was very easy. But the surprise came when we brought down location service. My expectation will be there will be some kind of internal failure, but nothing will pop up to the website. I was absolutely incorrect. Straight away, a 500 error is shown to the user, but that was not the main purpose of the page. You're browsing for a property, you should see the listing. The distance is not so important. So what we did is go back to the drawing board and then make this a component that if it's not present, then we can serve a degraded experience, meaning that then you don't get the distance to the property, but you still see a full property listing. And that was a kind of quite enlightening of how important it is to test and to introduce chaos into your architecture.
Yeah,
what happened next?
What happened next? Well, I don't know if you all remember this one in 2016, the Sydney outage the AWS Sydney outage. So those lessons of the zombie apocalypse at REA, and then also the lessons around building MyFun, I think that really put REA in good stead for this thing that occurred in 2016. So by 2016, REA had migrated a bulk of their infrastructure over to AWS. And included the main consumer website, realestate.com.au. So In designing the website in AWS, RE decided to go multi-region, similar to how the images were constructed. The main consumer website at that point in time in 2016 was pretty straightforward. It was mostly read-only. There was some rights for save searches for someone logging in and being able to save stuff to a feed, but it was mostly read-only, so it was quite simple. So when the incident occurred in Amazon, the CDN was automatically able to divert traffic from one region to another. And Jeremy Button wrote a really good blog about what occurred during that 2016 outage in the previous slide that's linked, and we'll share the slides afterwards. There was also some stuff in that REA group had that was deployed single region that were affected by the outage in 2016. But predominantly the concept of business criticality, the things that were really important for REA group were multi-region and were fine during that period of time. So that was a good win for REA group. So I think reflecting back, 10 years ago, like our lessons from our time at REA group, I reckon these 4 lessons that we have. So cattle, not pests when you're in AWS or in any type of cloud, designed to fail, and shift left, and then testing for that failure. I think that really put REA in good stead for their cloud journey after we left. And then we left, and you moved on to Slack. So what are some of the memories, incident memories at Slack when you were there?
Yeah, Slack was a really interesting environment with a global product and a really important tool that many of you probably use daily to work. And I was like year 2021, enjoying the beach. We were in Wilson's prom, ready to go back to work for the new year. It's gonna be fine. Everything is gonna be okay. So first day back at work, I think it was the 4th of January. Everybody's like going back, and I'm going to try to give you an overview of what our systems look like at that point in time. This is a simplified view again of the systems. We have one bubble with our compute. Each one of those like blue bubbles probably represent a few hundred instances in AWS, and they're serving the main Slack API. We have these services inside the compute section, which is called provision service. Every time that we create a new instance, that's the service that will tell the instance what's their purpose. You're here to be a web server, you're here to be a database, you're here to do this job. And it gets hit every time that we bring up new instances. We have a whole monitoring stack that includes logs, metrics, traces, and like users are normally using the dashboards to see how we're doing. And we have the usual alerting through PagerDuty. Down there, we have the network component. So we recently moved to a new network architecture. We've divided into multiple accounts. We initially were in a single account with thousands of instances. That was a problem, so we started to segment that into different accounts, and we're connecting those through Transit Gateway. Everything, as you can say, is working fine, and Slack status is okay. We're doing fine. So the day starts, and as you know, the sun goes on, and we start in Australia, so we ramp up our user base in the Asia Pacific zone, and everything is running fine. That's like probably 1 a.m. Pacific, and we're doing all right. The next bump is when everybody in Europe wakes up and gets on to work, and we went through that space. Probably we scale up a little bit of our compute, but everything is fine. Nothing is having trouble yet. So we get the first alert around 7 a.m. Pacific. We are seeing some packet loss happening in the network. Something is not going okay, but that's the only symptom that we are seeing. So our incident response process starts, and engineers start to kind of investigate what's going on. There's something weird, but you still don't know what it is. Next, we completely lose all visibility. All the dashboards and all the alerting stop working. So at this point, we were completely flying blind. We can still SSH into servers. We can still look what's going on. We can use AWS, but we don't have a clarity that you get from your monitoring tool set. So we're starting a little bit to panic. What's going on here? This is not normal. Next up, we see that there's a small downscale in our compute platform. So we scale up and down based in 2 factors. One of them is CPU utilization, which is normally a good metric to use in your scaling. And the second one is how busy our Apache thread workers are. And because the CPU is starting to be a little bit low, even if we are getting more users into the platform, we downscale our compute layer. This was because the machines are not able to do their work because they're not able to reach the dependencies because of this packet loss that is happening at 7 a.m. Still able to serve a Slack at that point. Next up, the second metric kickoffs, and because we've downscaled those machines, those hundreds of machines, then we decided to do what is like normally a very common operation in Slack, which is massively scale up. So we just told AWS, can you please give us 1,000 instances? And as I say, this is an operation that we're doing all the time. We're scaling that fleet, which is quite massive on a regular basis. But because of these packet loss, and we were in a weird state, that didn't go very well. So next thing that happened, well, at that point, Slack starting to be quite slow. Users started to notice that something is not going well. Well, when we ask for 1,000 instances, and we practice this a lot, suddenly provision service completely goes hard down. The problems that we're having in the network are making that service to hit a lot of limits. Some of them were AWS related, some of them were related to how we configure this service to operate. The usual too many file descriptors open that you hit all the time. But this has never happened because provision service was so quick to do their job that we never encountered this problem before. This now was at play because of the combination with the packet loss. So you can see things start to build up, one on top of another, not a single thing happening, but the combination makes that we don't have enough capacity to serve Slack. The three blue bubbles are representing the machines that are doing work. The rest, because they are trying to reach the provision service and ask for, what should I do? What's my mission in life? And provision service is like, not responding, then they're like sitting idle there and they are not being able to provision, which created a problem. We have a lot of, maybe we can call them zombie instances again. And it's like they're doing nothing but just using space in our auto-scaling group. 7 a.m., Slack is hard down. So lots of work later, we were fixing stuff in all places. We were able to recover provision service to certain extent, removing some of those limits. And we started to kill those instances that are doing nothing and sitting there using capacity. And we start to kind of manually being able to add more capacity to our compute. We see that the Slack is slowly recovering. We start to be slow, but still being able to send messages around 8 a.m. So provision service is now fixed. We're able to provision enough compute capacity, and now we can serve our customers, and messages start to flow as usual around 9 a.m. But packet loss still continues. We're working very closely with AWS at that point to try to investigate what was going on, what's causing the packet loss. At some point, AWS finds out that the transit gateway infrastructure was not scaling at the rate that we needed for the amount of packages that we are sending. You can imagine when the US starts to take over and starts to get more users into the platform, we get a spike, and that spike was not well received by those transit gateways. So AWS ends up scaling manually some of those transit gateways to a capacity that can work for us at that point. And we're still not having our monitoring back. So when that fixes, then around 11 a.m., we are all clear, all our systems are back. I think the one thing that I probably wanted to highlight as part of this incident is how there's not a single failure that normally brings you down. It's going to be a combination of things, and it doesn't matter how much you prepare. At some point, you're going to find things that are not great. And at that point, you need to kind of be prepared to react. There's a nice blog post from Laura Nolan, which was one of the SREs at Slack, in the Slack tech blog that you can read. You can imagine that behind the scenes there are like 1,000 things happening. There's like hundreds or maybe thousands of engineers trying to solve things, and you don't want them to kind of collide and like being trying the same things or maybe undoing the doing from other people. So we had a really rigorous incident process that we will follow, and that will like normally happen at Slack. But what happens when Slack is down and Slack people are trying to recover? Well, you need to practice those scenarios as well. That was something that we also have very well prepared. There was always a same Zoom call that is always open to respond to an incident. We had 2 or 3 different fallback mechanisms for communications in case of Slack being down and not being able to use it as our response tool. There's another nice blog post that goes over this. We'll share the slides at the end, and you can access all the blog posts if you want to go deeper into any of this. So what happens when like a company as Slack has this big outage when the whole world is coming back from the Christmas break or the New Year break and they want to work? Well, you may appear in one of the pages of the New York Times, or maybe you will get a tweet from your friend Trent saying like, Javier, when are you going to fix the Slack?
Yep.
And then the most important part is like, what are we going to learn from all these incidents? In companies all across the globe, there's these type of things happening all the time. Many companies run these processes called like incident reviews or PIRs, and previously known as postmortems. I think we're moving away from that term. And they like look a little bit like this. You want to understand the timeline. You want to identify the contributing factors. I like the word contributing factors. I want to move from root cause, especially in singular versions. It's like there's no single root cause for this incident. As you could see, there were like 5 or 6 things that need to happen in a sequence to make this incident possible. Learn what was good, what was bad, and how we got lucky. I think there's always like that component there. And then normally you come up with a list of follow-up items, and more importantly, you can like go and share those lessons learned inside the organization, because everybody can learn from them, and beyond, right?
So remember, so I was at Catch before I was at Seek, and there was a couple of big incidents that occurred, and so we do a post-mortem, and then we ended up coming up with like a long litany of action items, and I'm thinking to myself, there's no way we're going to do this. And then equally, like, what is the value of some of these? So how did you manage that at Slack?
Yeah, I agree, Trent. There's this tendency of come up with a lot of things coming out of an incident, especially if it's a big one. You were when we're preparing the talk, you were mentioning about add more monitoring.
Yeah.
Like who has had like an action item from a postmortem?
Add more monitoring.
It's like, yeah, that's sometimes good, and like you get to a point where monitoring is too much, and then you're like, okay, reduce monitoring, because that's everybody's like being woken up all the time.
Take away monitoring, is that the?
Yeah. So what I really like from this incident in particular is that the actions that we took on from there were really impactful and really make Slack more resilient. The first one was like easy, adjusting our scaling policies. We learned a lot through the incident about how they work and they didn't. And we also introduced the concept of predictive scaling. So we know we have a pattern in the usage, so we use that to inform our scaling and not do it only on the factors that I talked about before. We fully redesigned provision service to eliminate some of those components that could hit limits. And we even tried to get rid of provision service all around. Like, why do we need this in the first place? We ended up needing one, but we created a much lighter version of it that had less limits. We worked really hard with AWS. We pushed them hard about how the transit gateway auto-scaling infrastructure works. And they did a great job at like now offering that to all customers. So I think that we are all benefiting from that. And then we expedited the migration to the new architecture, the network architecture, because like having one leg in each one of the accounts and not being able to communicate between those was one of the problems that we're finding. So I think that what I'm trying to convey here is that find those changes in your architecture, find your changes that are going to really make an impact going forward, and maybe just avoid the add more monitoring.
Maybe.
So there are many incidents on Slack, and I think Laura created a really good trend to share those lessons out to the community. You can now go to the Slack tech blog and read about them, read about the causes. And I think that as an industry, we have a little bit of a fear of sharing when things go wrong. And that's something I think we can change, and this is a good start. I also really valued how the people that manage our Twitter account always had like a little bit of humor behind like sharing a very impactful component like that other incident that we had in that date. I think it was a little bit of the mentality back in Slack.
Yeah, cool. All right, that's an interesting, good story. So, so I guess you look back. So Slack had some issues. A couple of issues. We talked about like the ARIA group, zombie apocalypse, and there's been many failures at Catch where I was previously. And Vina Vogel says, everything fails all the time. So I guess the question is, why not disrupt yourself? Because if you're going to be disrupted, why not introduce some chaos engineering into your ecosystem and learn from those failures before your customers find them out for you? So it's like, all right, well, what do you want to do? How do you introduce chaos engineering? And I think there's really three things you want to consider before introducing chaos engineering. Firstly, you need good observability of your ecosystem. So, for instance, if I'm on Seek and I'm searching for jobs and things aren't working, I want the observability to tell someone. I want the observability to generate a signal. Secondly, I want an observability tool. If I'm picking a tool, I want an observability tool that developers want to use, because like observability, a chaos engineering tool is for those developers. So you want something that developers want to use and can drive. And then thirdly, you want to be able to have a tool that can introduce failures and turn up the dial on those failures. So you want to be able to learn how to drive the car before you're driving in the F1 race. So there's a long litany of tools when it comes to chaos engineering, and then equally for observability. Netflix really pioneered chaos engineering with the Simian Army back in 2012. And so since then, there's a long litany of tools, and then equally there's a long litany of full-service observability tools. Each of these tools have a lot of varying trade-offs, and there's a lot of tools that aren't on this slide here. So there's a lot of variability around what you can do if you want to introduce chaos engineering. In terms of introducing chaos engineering, I've got an interesting story. So before I was at Catch, I was at a betting place, and we're doing a cloud migration from data center to AWS. And to ensure that this betting platform would work during Melbourne Cup, I introduced Netflix Chaos Monkey into the staging environment. So the migration path was, let's migrate the workload into staging, then into production. And then this gave a lot of confidence that when things were running in production, that it would probably work. So when implementing chaos engineering, it's pretty easy and straightforward to introduce it into a greenfields environment like the example I spoke about. When it comes to brownfields, it's a little bit harder, but there's a couple of levers that you have. Firstly, like the betting example I gave, you can introduce it into a non-production environment and then run it. It's probably going to surface up the big issues, or surface up issues. And secondly, you can run the chaos engineering tests that are out of hours in a maintenance window. And then third, you can simulate a really low risk failure, like an EC2 instance failing, before you simulate an AZ outage or any other business metrics that the business want to validate to ensure you've got a resilient architecture.
Anything else in this one?
No, I don't think so. Am I missing something else?
No, I think you're good. You're good.
I don't think so. All in all, really value chaos engineering. I was brought on at Seek to validate the risk and resilience program, and that was one of the key things, was how can we introduce chaos engineering into the ecosystem? Because that's the best way to figure out whether the website is working, and if it isn't working, how we can disrupt ourselves so that we know what to do before customers are telling us. So I guess, you check out what's going on in the community and all this stuff. You're involved in a lot of communities. So what have you picked up from other places around how what in their instance they've published out to the world?
Yeah, I think it will be interesting to share some of the stories that we saw out there. And one that really stuck with me was this one from Monzo. So Monzo is a bank in the UK, one of these modern banks, and they created the infrastructure from scratch, and hundreds or thousands of microservices, and using Kubernetes and bleeding edge technology. And then we had them come into Container Camp. It was did anyone go to this talk at Container Camp here in Melbourne? I really like this story, and they jump in the stage and talk about how a random bug in gRPC that was introduced in etcd, which is part of the Kubernetes ecosystem and helps to run your services, introduced this problem and this incompatibility into two components they are using. So they're using Kubernetes, and they are using Linkerd as a service mesh to make the communication between services work. And because they introduced this bug, a really latent condition happened where, like, you reduce one of your deployments to 0 replicas, so it's like, we don't need this service anymore, we just go to 0. Whenever they're like checking what's happening, the response from etcd changed. And at that point, whenever they did a new deployment, that new deployment was not able to use Linkerd correctly. So they were not able to communicate to other parts of the system. So they're doing a deployment of the ledger system, which is in a bank is a very important component. And then that cannot communicate to anything. So at that point, the team is like, what do? We're responding to this incident. Maybe we should restart all our Linkerd components. And by doing that, they introduced that back to everywhere, and they were not able to communicate. Luckily for them, they had like a fallback mechanism where they could process credit card payments without having to use the ledger for a period of time, and then they figured out what happened and fix it. But what I really value, apart from this story being very cool and like introducing different components, and similar to my story at Slack, is these different things that have to happen for it to become real. It was the braveness of coming to the community and sharing that with the rest of the world. The second story that I want to share is from my colleagues at Canva, and it talks about what to do when a recommended system fails. And the reason why I'm sharing this one is because it shows that different systems will have different failure modes. And maybe for a web server or for an API, the failure mode is like, I'm not able to respond. But what are the failure modes for a recommended system? Maybe it's not giving the right recommendations to the users anymore. Maybe we recompile that model, and now we're like offering the wrong recommendations to people. Or maybe it's not offering any recommendations at all. For example, the blog post goes over the cold start problem, where like if you're new to the site and we don't have any information about you, our possibilities of recommending a template or recommending an image are going to be very low. And then what to do if your system is failing? Can you compile a new model and like deploy it before like the incident is becoming very big? And like compiling these like large language models are like, it takes a long time to do. So what the blog post talks about is like maybe in those cases you want to roll back a previous model, even if the recommendations are not going to be so accurate. I think like the lesson here is like, how do you learn about the failure modes and how different systems will operate? And what about you, Trent? What's one that is stuck in your mind?
Yeah, okay. So being from online retail like Catch, I know Black Friday is like the biggest sales day for Catch, and I imagine it's the same thing for Amazon. The Turkey 5 is like sales day. It's like Melbourne Cup. And so this one piqued my interest when I was looking at the reInvent catalog, last reInvent. There was a talk about this outage here. So what occurred in 2018, Amazon.com was down for a couple of hours. Really fascinating. They experienced what's called congestion collapse. So simply, congestion collapse, what had occurred was there was an upstream system that failed. It hit some resource limit. And then in the architecture, there was a lot of synchronous dependencies that were downstream. And so this upstream system failed, and these synchronous dependencies, the failure wasn't propagated back to the root client, and these synchronous dependencies were executing their retry logic without propagating that failure back. So eventually, the engineers were like, all right, figured out what the problem is, we've got some queue. So they implemented a fix, but they weren't able to recover the system because they're effectively DOSing themselves with all of the retries. So while exponential backoff and retry logic can be really useful to navigate around failure, it can actually cause failure like it did here for Amazon.com. And so we see this scenario on freeways. So if you've got a busy freeway and then you've got a flood of cars on the on-ramp, you're like, oh crap, the traffic just grinds to a halt. It's super annoying. And that's effectively what occurred with Amazon here. All of the systems were busy trying to do some stuff, but there was no productive work being done. So the way that we solve this on freeways is traffic light on-ramp systems. And their main purpose is to prevent the surge of traffic and block that surge traffic. So if in your architecture you've got a lot of synchronous dependencies, consider how you can implement that traffic light system in your architecture because it'll probably save you. So at my current workplace, over the past couple of months, there's two hot topics, and I don't know, I reckon this is a pretty hot topic at various other places. They are, what are you doing about multi-cloud, and what are you doing about multi-region? So I'm not going to talk about multi-cloud because that's another talk for itself. But I'll talk about multi-region in the context of AWS. So the 2014 me says, it's super easy. ARIA Group did it. But the 2024 me says it's actually really, really hard. There's really three reasons why you want to go multi-region in AWS. And that is if you've got some data sovereignty requirements that warrant you putting stuff into a specific region. Secondly, if you've got you've got really low latency requirements, particularly on writes. And then third, if you've got a scenario where you just don't trust the region, you want more nines than a single AWS region can offer. So those are really the three things. But there's a lot of complexity because what do you do about writes? So if I take the Seek example let's take Seek as an example. This is kind of similar to what Seek has in terms of architecture. There's GraphQL at the front, and then there's a lot of downstream, a lot of dependencies. And then, so what do you do when one of those systems fails in one region? Like, how do you divert traffic? What do you do about gray failure? What do you do about deploys? What do you do when you can't sync that data from one region to another, and then the customer is bounced to a different region? It's a lot of complexity, and that means a lot of cost. So AWS has a concept of global services, regional services, and zonal services. So simply a global service are things that power all of AWS, like IAM roles or DNS. And then there's regional services like, they're more like platform as a service, so like DynamoDB or Lambda functions. And then there's zonal services like an EC2 instance in a single AZ. So you basically pay more for Aurora RDS, which is a regional service, but Amazon guarantees it to work whenever there's an AZ issue. Whereas it's your responsibility if you've just got stuff in EC2 to navigate around a failure within an AZ. So inherently, you're trading off cost versus complexity, but sometimes that cost is worth it. So I think, then reflecting on back at REA Group, REA was multi-region for their main listings website. And we spoke about the outage that occurred within AWS in 2016. That actually wasn't a regional outage within Sydney. That was a single AZ that was out. What occurred was a single AZ was out, then there was some grey failure within the other AZs, and then it appeared to be a set of contention in the other AZs. So you couldn't launch an instance in another AZ at that point in time. So I guess reflecting back, what could have REA have done differently? Maybe if they used a accompanying set of regional services and zonal services and pre-purchased those zonal services to cover them for an AZ outage, maybe they wouldn't have needed to go on multi-region. Maybe it would have been cheaper, maybe not, maybe it would have been simpler, maybe not. Another thing that, reflecting back, maybe REA could have considered is this concept of cellular architecture, which is, I guess, limiting their blast radius of failure. What is cellular architecture?
Yeah, so the original architecture of Slack had like everything. Some services were running in a single region, and we're using the pattern which was like recommended at the time, which is have all your services being multi-AC by default. But what we saw during some of the incidents that we were having is that a single problem in an AC could propagate to the rest of the entire architecture. Because every server is talking to every other server, so they're not keeping the traffic in one area. So the failures could propagate really easy. There's no a good boundary for retaining failure. And sometimes those were AWS failures. Sometimes they were our own failures. They were we're doing a deployment, we introduce a problem into this area, and it's propagating everywhere. So the way that we went about it is to implement cellular architecture, and the way that we went about it is to create this concept of a cell is an AC, so everything that is inside a cell should be sufficient to serve the service that they are providing, and will not have to go out of the cell to perform their service. So everything is self-contained in there, So at that point, we were able to move traffic away from faulty AC or faulty cells, and then maintain the availability of the system. And there's a really nice blog post from one of my ex-colleagues there that goes all over how we implemented cellular architecture, which I recommend reading if you're interested. And that brings us to the very end of the talk. So I'll quickly summarize what we've talked about today. So we know that things break all the time, and we need to prepare for those. It's very important to have a learning culture organizationally to kind of like move forward and to try to avoid those incidents happening in the future. We share some of the patterns that you can use, like chaos engineering or exponential backups and retries, also the graded mode that will save you some of the problems, cellular architecture at the very end of the talk. Practice your incident management processes, even if your incident management process will need some backup procedures as well. And then share the lessons initially internally within your organization. It's like there's no point of having a document with an incident review somewhere that nobody's reading. And if you want and you want to try help the rest of the community, why not go in and like telling everybody about it? So with that, I want to give you an icebreaker exercise for the rest of the conference. So when you're meeting people out there in the hallway, why not asking about like an incident that maybe they've been part of, or what were the lessons learned, or like an incident that they read about that that could be an interesting topic to do. Why not trying this? With that, thank you so much for listening. I hope that you find our talk entertaining and useful. If you have any questions, you can ask them there. That QR code will give you access to our slides, and you can find all the links to the blog posts that we talk about today. And yeah, if you find us in the corridors, just come and talk to us about lessons learned and incident. Thank you so much. Thank you.